According to Creation.com, the Cambrian explosion provides some of the most devastating fossil evidence against Darwin's theory of evolution. They even claim that the Cambrian explosion is, quote, often referred to as the Big Bang of evolution because dozens of widely different organisms are said to have arisen over a very short period of time. And then they list a few here in their article, even saying that there is no evidence that these species from the early Cambrian are somehow less sophisticated than their representatives alive today, which is just baffling considering that they literally have Hykuichthyes right there, which they've characterized as just a type of fish, despite the fact that it lacks paired fins, jaws, spine, vertebrae, even a properly developed head, scales, fins with rays. I mean, it goes on. Even putting aside the individual examples of dishonesty in these young earth creationist institutions and websites, the Cambrian explosion is still an extremely commonly abused concept by creationists, both professionals and laymen on the internet and in public. There's a common misconception about the Cambrian explosion, like it's just this sudden creation event of all of these modern phyla that we have today. In fact, most young Earth creationists could not even pronounce the name Ediacaran, which is the period which preceded the Cambrian period. Much less does the average creationist know anything about the types of animals that lived in that period, several of which are pictured here behind me now. But a new fossil discovery in South Australia puts the creationists on the back foot once again as their God of the Gaps arguments retreat further and further into the ever narrowing gaps. Meet today's newly discovered gap filler, the world's oldest known Ecdysozoan. The Ecdysozoans are a group of animals known for undergoing ecdysis, which is basically just the shedding or molting of an outer hard membrane or cuticle. So Ecdysozoan literally means the shedding animals. Well-known examples are the arthropods, which include all of the insects and the crustaceans, as well as nematodes. Now, the arthropods, their outer layer, their cuticle, are their exoskeletons, which are made of chitin, which is like a specific type of sugar alternative that has a little amide nitrogen group added to it, and then it's just chained together and cross-linked into a bunch of collagen and different types of proteins to make this really, really hard structure that they can then support as a skeleton for the rest of the organism on the outside. Nematodes, however, don't have chitin in their cuticles, although they do still do ecdysis and they molt whenever they grow. It's just that their cuticles are composed of, well, like, it's a little bit more primitive. It's still highly cross-linked and still harder and more stable than like more softer bodied organisms, but it's composed of like primarily just like the collagenous proteins, and like different glycoproteins, which are also based on like glucose sugars. So it's like a little bit less sophisticated and less strong than the more chitin cross-linked, where like the chitin is literally interwoven into this protein structure in arthropods. So why am I telling you all this? Well, because just up until recently, the Ecdysozoans were just one more of those groups that the creationists would commonly point to and say, oh, look, there's just one more group of animals that just has this out of the blue appearance in this explosion in the Cambrian period, right? Well, they can't say that anymore. Meet Uncus dzaugisi, the newly discovered Ecdysozoan in the Ediacara period found in South Australia, the oldest known Ecdysozoan ever found from the pre-Cambrian period over 550 million years ago. Incredibly, over 80 individual specimens were found. Now, superficially, this Ecdysozoan resembles a nematode, which are fairly primitive looking. It has a smooth, undifferentiated surface, rounded ends on either side. It's quite small. Not a whole lot to talk about in terms of its appearance, but there's a lot of interesting details when you open the hood. Now, before this discovery, there had been no other nematode like organisms found in this period before the Cambrian. They're not fully nematodes because, again, it's really hard to identify these things just based on these fossils here, but these are very nematode-like, nematoid. So these nematoids are identified as such in the paper announcing these discoveries because they have a unique property relative to all the other ediacaran similar animals that we found. You find a lot of worms. It's kind of like worm world back then. I mean, underneath the surface of all of these strange, plant looking animals behind me, there's a lot of worms burrowing down there, right? And these Uncus might have been one of them. And what makes these Uncus nematoids so unique relative to all the other worm-like fossils we find from this Ediacaran period is the depth of their fossil reliefs. They're so deep relative to the other shallow reliefs of these soft-bodied worms, suggesting the presence of a hard cuticle surface, thus putting them in this category of nematoids in the Ecdysozoans. And once more, there are nearby trace fossils, which are called ichnofossils, where the fossils don't have the organisms themselves, but they are like preserved fossils of organisms' activity. And specifically, these ichnofossils associated with these Uncus nematoids are very sinusoidally shaped as described in the paper. That's why they called them Uncus worm. Uncus comes from the Latin for hooked, okay, describing these kind of hook sinusoidal shapes of their track patterns in the actual rock. Now, based on DNA and molecular studies, we already had an idea that the Ecdysozoans likely differentiated way back before the Cambrian explosion ever happened in the fossil record. However, we didn't have the fossils to back up that hypothesis until just now with Uncus. Also, guys, I gotta admit, I love saying that name. Like, hey, Uncus. I mean, it's just great. The species name, though, dzaugisi, it's named after a specific family, and I'm like really not sure if I'm pronouncing that right, but props to them. This is an awesome discovery. I mean, the oldest Ecdysozoan pushing back our evidence of this evolution. Remember, this group includes all the arthropods, which are the most numerous species on Earth. I know that for some annelid creatures in the later Cambrian period that scientists have actually been able to show that they had chitin in them. So like, this would be a really cool fossil to see if they could do some sort of biochemical analysis about what the composition of those cuticles are. I have a prediction here of a maybe evolutionary hypothesis that if we are able to chemically test the composition of these Uncus cuticles, that they will be very, very primitive compared to nematodes of today. So let's see, maybe a future subsequent paper or work from other scientists will shed some light on this, but I'm putting my prediction on the public record today. See how this one successful prediction of evolution, the existence of Ecdysozoans in the Precambrian layers in the Ediacaran, leads to further predictions that we can falsify to test to see whether or not evolution is a valid theory. And the fact that we predicted that we should find Ecdysozoans in these layers, which we had never found them in, and now we have found primitive Ecdysozoans in these layers, is yet again vindication of evolution above these young earth creationist apologists and their bloggy websites. See how that works when you're doing actual science, creationists? One other thing of note about this study that I think is really cool is that this Uncus fossil actually came from a layer in the Ediacara Hills in South Australia, where the actual Ediacaran period gets its name from. So this is like, a new discovery in the OG rock layers where this whole period originates from their discoveries. I mean, how cool is that? And this study also, the scientists in the study say that this layer in particular, they're very excited to keep looking in because the grains are very small and allow for really fine detail preservation in these fossils. So I am very excited to see what new discoveries come out of this new layer in these Ediacara hills that they're looking in now. I mean, we've already got this fossil find out of there. What else remains to be discovered? By the way, the topic for this video specifically was chosen by a poll of my patrons over on my Patreon, where every month you get to decide what topic you want me to make a Patreon exclusive video on, and it'll be only on the Patreon for 6 months before coming on the channel. This video is the sole exception because this is the very first one that the Patreons have selected. So I wanted to give everyone a taste of what these kind of videos and what this content will be like over on the Patreon. So I will see all of my patrons next month, and the rest of you on the public channel, I will see you in 7 more months for the next installment. If you're still curious about the Cambrian explosion, I do have a whole video about the subject. Check out the link in the description. And please subscribe and hit that notification bell for more. See ya.